Engineering Mathematics 2, Anna University question paper, April-May 2018. Question number 15B2. Solve y double dash minus 3y dash plus 2y equal to 1. Given that y of 0 equal to 0, y dash of 0 equal to 1 by Laplace transform method. Okay. So by Laplace transform method, the given differential equation can be rewritten as y double dash of t minus 3y dash of t plus 2 into y of t equal to 1. Taking Laplace transform on both sides. By taking Laplace transform on both sides, Laplace transform of y double dash of t minus 3 into Laplace transform of y dash of t plus 2 into Laplace transform of y of t is equal to Laplace transform of 1. Now the formula for the Laplace transform of y double dash of t. So these are all our required formula. To solve the differential equation, we have to use the following formulas. Laplace transform of y of t equal to y bar. Laplace transform of y dash of t is equal to s y bar minus y of 0. Laplace transform of y double dash of t is equal to s square y bar minus s y of 0 minus y dash of 0. So using these three formula here, y double dash of t is s square y bar minus s y of 0 minus y dash of 0. First formula, y double dash, Laplace transform of y double dash, minus 3 into Laplace transform of y dash of 0, y dash of t is s y bar minus y of 0 plus 2 into Laplace transform of y of t is y bar. Finally, Laplace transform of constant, Laplace transform of 1 is 1 by s. Now, after using these three formulas, now I am going to substitute the given initial condition. The given initial conditions are y of 0 equal to 0, y dash of 0 equal to 1. So, put y of 0 is equal to 0, y dash of 0 is equal to 1. So, substituting here, s square y bar minus y of 0 is 0, so that it is 0, minus y dash of 0 is 1. And minus 3 into s y bar minus y of 0 is 0 plus 2y bar is equal to 1 by s. Now I am going to keep y bar term here, other terms are taken to right hand side. So next simplification, keep all y bar terms in the left hand side, other terms are taken to right hand side. That means here s square y bar minus 3sy bar plus 2y bar. The remaining one term minus 1. Take minus 1 that side plus 1. 1 by s plus 1. So now commonly take y bar term outside. So taking y bar outside, s square minus 3s plus 2 is equal to, take here 1 plus s by s. So now you take y bar for term. So 1 plus s by s into s square minus 3s plus 2. Take the term here. Now y bar is L of y of t. Y bar is L of y of t. And now here 1 plus s by s into quadratic equation. Factorize this. The factorization is s minus 1 into s minus 2. So now I want to find out y of t. Take L term here. So y of t is equal to L inverse of 1 plus s by s into s minus 1 into s minus 2. Take equation number 1. So here I am going to find L inverse of this. To find L inverse of the given term, I am going to apply partial fraction method. So apply partial fraction for the inner term. So by partial fraction method, 1 plus s by s into s minus 1 into s minus 2 is equal to a by s plus b by s minus 1 plus c by s minus 2. Taking LCM, so common term I am going to cancel. So 1 plus s is equal to a into the LCM s into s minus 1 into s minus 2, cancel the denominator. So here the a having s term, so the remaining terms are s minus 1 into s minus 2, so that this is s minus 1 into s minus 2 plus b into b having the denominator s minus 1, the remaining terms are s into s minus 2, so s into s minus 2 plus c into c having denominator s minus 2, so the remaining terms are s into s minus 1, so s into s minus 1. So this is the term. So here I am going to substitute some values for s to find the values of a, b, c. The same term I am taking here. The same term is 1 plus s is equal to a into s minus 1 into s minus 2 plus b into s minus 2 plus c into s minus 1. So now to find the values of a, b, c, so first I am going to put s is equal to 0. When you put s equal to 0 here, 0 plus 1 is 1. When you put s equal to 0 here, minus 1. So a into minus 1 into minus 2. The remaining terms are 0. When you put s equal to 0, 0. S equal to 0, the entire term 0. Now by simplifying this, you will be getting a value is 1 by 2. So we found a is equal to 1 by 2 by putting s equal to 0. Now next I am going to put s is equal to 1. Then it will be cancelled a term and c term. So put s is equal to 1. By putting s equal to 1, 1 plus 1 is 2. By putting s equal to 1, the term 0, here only. So b into 1 minus 2 is minus 1, which implies that b is equal to minus 2. Next I am going to put s equal to 2. By putting s equal to 2 here, 2 plus 1 is 3. By putting s equal to 2, 0 here only. So c into 2 into 2 minus 1, 1. So which implies that c value is 3 by 2. So we found a, b, c values. Substituting these values in equation number 1. So equation number 1 is, this is the equation number 1. Actually the value is equivalent to this. So I am going to substitute a, b, c value here, but this value is equal to this. So this can be directly substituted in equation number 1. So equation number 1 implies y of t is equal to L inverse of this. This is equal to this. So substituting a value, b value, c value. So a value is 1 by 2. So 1 by 2 by s. B value is minus 2 by s minus 1. C value is 3 by 2. So 3 by 2 by s minus 2. So substituting all the value, a value, b value, c value, s into s minus 1, s minus 2. Okay. Now I am going to take L inverse inside. Taking L inverse inside, so 1 by 2 into L inverse of 1 by s. Because when you take L inverse here, take 1 by 2 outside. Now next term, minus 2 take outside, so L inverse of 1 by s minus 1. And the last term, take 3 by 2 outside, so L inverse of 1 by s minus 2. So okay, now I am going to find y of t value. Y of t is the solution of the given differential equation. So 1 by 2 into L inverse of 1 by s is 1 minus 2 into L inverse of 1 by s minus a is e power at. A is 1, so e power t, plus 3 by 2 into L inverse of 1 by s minus a is e power at, so e power 2t. So finally the solution of the given differential equation is y of t is equal to 1 by 2 minus 2 into e power t plus 3 by 2 into e power 2t. So this is the answer of the given problem.